Hello everyone, my name is Rocco Ancora, Canson Infinity Ambassador, and today I'm going to show you how to optimize your files for print. Now, when you're printing your files, you have to make sure that they are optimized in order to get the best possible quality out of your printed image. So there's a few things that need to be addressed. In this video, I'm going to discuss the importance in understanding the difference between file resolution and print resolution and how this affects the overall print quality. One of the questions I get asked a lot is, how big can I print my image? So I'm going to show you how to interpolate or resample a file in order to maintain the best quality possible. Also, the most important part of the print workflow is sharpening. So we need to understand when to apply sharpening, but most importantly, just how much to apply. The last step, of course, is soft proofing and the role of paper profiles. So there's a lot to get through. So let's get started. Okay, so I'm going to begin this video with sharing with you my overall print workflow and how I work from start to finish. So once I finish working my image and I have my layered file, whether it be a PSD or a PSB, that remains my master file, if you like. What I do with that file, of course, once it's saved, is I duplicate it, I flatten it, and I save that as a TIFF. Now, keeping in mind that I'm always working in 16-bit, okay, so I'm getting the best possible quality that I can in my file, in my tonality, etc., and I want that, of course, to translate into print. So we have the master file that sits, on the hard drive, and the master file copy that we do all our printing from. So this master file copy, I'll use this to resize it depending on the size of the print I want to make, but also do things to it like sharpening and so on and so forth. So the first thing that we do once we have our copy opened inside of Photoshop is size the print, and we're going to go through sizing in just a few moments. Sizing the print. Then once the print is sized, we will go through the sharpening process. Once that is completed, we will go through the soft proofing process, and then finally, we will print the file. So that's a little bit of an overview of the workflow, and hopefully as we go through this tutorial, you'll understand as to why we do certain steps at certain times. Okay, so let's begin with resizing images for print. Now, when we capture an image with our digital camera, each camera has a finite number of pixels. So a 24 megapixel camera has 24 million pixels to record color and tone. A 16 megapixel camera has 16 million, and so on and so forth. That number is fixed, and we can't change that. Now, when we open the file in Photoshop, we have the option of assigning any resolution we want depending on how far apart or how close together we choose to space the finite number of pixels. So, resolution then is just a measure of how, your pixels are spaced. What's important for us to understand is that image size and resolutions are linked. So let me show you here in Photoshop. We have an image here that's open, and if I go into image, size, we have our image here, and we have our image size dialog box. And first thing I'm going to do is I'm going to unclick the box of resample here, and I'm going to have the three clicked: the height, width, and resolution. Those three parameters are linked together because of the finite number of pixels that I mentioned that this particular camera has. So this was shot with a 24 megapixel camera. So it's a Nikon Z6. So we have a pixel count of 4,024 pixels by 6,036 pixels. So that number is fixed. Now, at the moment, the resolution is set to 360, and it's giving me an image size of just over 11 inches by 16.767 inches. Now, if I choose to bring that resolution down, let's just go down to 100 pixels per inch. What I'm doing here is I still have a finite number of pixels, but now they're being spread over a larger area, okay, because our pixel density has decreased. So now we have a file that's 40 inches by 60 inches. And if I change the resolution here to say, 600 pixels per square inch, I now have a higher pixel density, but I also have a smaller image. So 6,000 pixels, 6.7 inches, I should say, sorry, by 10.6 inches. Now, what we need to understand is that resolution, right, is determined by where we are going to output the image. So whatever we're printing on, whether we are asked to produce a file that's 300 or 360 or whatever that might be, so that number is going to be fixed. So what happens in a scenario now when we need to upscale or downsize an image, so if I put this down to, I'm going to choose 360 pixels per square inch here, I have an image size of 11.178 by 16.767. Now, the minute I click resampling, you'll note that now resolution's fixed, but these two, width and height, these two parameters are the only things that are linked. So now if I go bigger, if I now choose to say go to a width of say 20 inches, okay, it'll automatically link to a height of 30 inches because those two are linked in the proportions that we have. But Photoshop now, to make this image bigger, has to interpolate or basically make up pixels, if you like. And there is a couple of different ways that Photoshop does that, which I'll explain in a minute. But I can also, I'm going to hit just the reset button here, I can also go the other way. And I could go down to say, if I wanted to make a smaller image that's only say, 5 inches wide, then the height of that image will be 7.5. So you'll note that, to achieve this, we're going to need to throw pixels away. So Photoshop, in resizing images, or I should say in resampling images, okay, with a fixed resolution, has to either make up information or take information away. So let's look at how Photoshop does that. And there's a couple of different resampling options down here, from preserve details with enlargements, preserve detail to by cubic. So the top section here deals with enlarging. The middle section here deals with reducing or making the file smaller. And the last bit down below deals with just a couple of different options that can be used for either. Okay. Now, before we get into the resampling side of things, I'm just going to cancel that. If you're using Photoshop CC, you need to go into your file and into Photoshop preferences, right down here into technology and preview, and you have to enable preserve details for upscaling. Now, what this is, Photoshop will use artificial intelligence assisted upscaling to preserve important details and textures while resizing images without introducing distortion. So this is a new feature that's inside of Photoshop. Let's go into image size, and let's bring up this dialog again. And if I have the resampling box clicked and look at the different interpolation modes here, you'll note that preserve details to is already in here. And the reason for that, as I just showed you, is because we have that box checked in our preferences. And that this preserve detail option is only there if you have Photoshop CC, which is the current version of Photoshop. So I'm going to click that for the moment. I'm going to show you how that works in making the image larger. At the moment, we have a width of 11 by 16 and a bit inches. Now, assuming now I wanted to make a 20 by 30 inch print out of this. So if I put 20 in the top, and I've got 30 down below, so those two are linked as a 2:3 ratio here at 360 dpi, which is what I want to output to. In a minute we'll discuss why that's at 360. But at the bottom here, this particular interpolation method allows me to control the amount of noise that might be introduced in the file because of the interpolation process. So the default is normally at 0, okay, and if we put that to 100%, you'll see that, and I'm not sure how this is going to translate in the video, making sure that this, of course, this preview window is 100%, I should say as well. So it's at 100%. So you can see that's quite smooth, and to me looks quite unrealistic, and reduced noise has produced a little bit of noise, which sometimes, depending on the paper you're printing on, I don't actually mind. It can work to your advantage. But normally I will just bring that up, probably about a third of the way, because a little bit of grittiness there in the file actually helps in hiding any imperfection through the interpolation process, and it can look quite good. But it depends on your own personal preference and taste, and you're going to have to experiment with this and see what works best for you. So at the moment, we have I can upsize this to a 20 by 30 image at 360 dpi. Now, if I was to leave this at automatic, what automatic does is that Photoshop picks the best one it thinks it should pick. Okay. Now, from the different tests I have done, Preserve Details 2 is the one that works best when you're trying to do enlargements. Bicubic Sharper is the one I would use if I wanted to do a smaller print. So just say now I wanted to do an 8 by 10 inch print, I would click on that one and size the print accordingly. Okay, so when we're changing the size of an image, when we're resampling up, we're interpolating new pixels, and when we're resampling down, we are throwing away pixels. One important factor that affects your perception of the quality of the print is the viewing distance. So as you stand further away from a print, you don't notice a certain level of detail loss or artifacting. So as print size goes up, it would be safe to assume that the viewing distance also goes up. So to answer the question properly on how big you can go, if we go back into our image size dialog, okay, and we go back down to our Preserve Detail 2.0, we can plug in our figures here of our desired size of where we want to go, and quite simply look at the preview and see how degraded or how bad or how good the image looks based upon the size that we want to print. Now, each image is going to vary. Okay, there is no set rule as to say if I've shot with a 24 megapixel camera or a 40 megapixel camera, I can go to a size of X amount, and so on and so forth. One of the things I also like to do now, if I am going beyond a certain size, so here I could comfortably do a 20 by 30 out of this, but if I wanted to go any larger, now assuming now I wanted to do say a 40 by 60, you'll note here that we're really starting to push the quality envelope. However, keeping in mind that this size print, okay, isn't going to be viewed at arm's length. Yeah, this size print, a 60 by 40 inch print, is going to be viewed from quite a big distance away. Okay, so this might actually work with a little bit of sharpening. Also, to eliminate just how much work or how much lifting Photoshop has to do, what we can do is apply the Preserve Detail interpolation, but in steps. So there is a method that is called stir interpolation. Let me just go back into the image size dialog. We will click onto the Preserve Detail interpolation method. And now, instead of just putting in the figure that we want to end up at, I'm going to change this to percent. And what I'm going to do is we are slowly going to build up this information at 10% in 10% increments. So here we'll have 110, and I will hit OK. So now this will be 110, 10% bigger than what it was. Then I'll go into image size, and I will hit 110% again. So in other words, what Photoshop is doing each and every time is that it's interpolating information, but only in 10% increment. Using this method, I believe it just does give you a better result, especially when you're going, to print, really big sizes. Assuming now I wanted to go down in size, I'll go back into image size, but not only do I want to go down, I want to say crop it to a specific ratio. Okay, so assuming now I wanted to do an 8 by 10. If I put in the height here of say 10 inches, okay, the width, because this ratio is linked, it's going to give me a 10 by 6.653, which is not really what I want, because it's not going to fit into an 8 by 10 mat if I'm using standard cut mats to put in my frame. So what I need to do is I need to go to my width, which is the smaller number, put in 8 inches there, and this is going to give me a height now of just over 12 inches, which means then I have to crop the size from either end, which is okay. So I'll click on the 8, I'll put in the 8 and the 12, And instead of using preserve details, I'm going to go into bicubic sharper for a reduction. I'm going to hit OK. So all I do then is go into my crop tool up here, and I select from the top here 4x5 or 8x10, and I've got the option now of actually moving this up and down to exactly where I want to crop the image. So once I'm happy with that, I click on the little tick, and if I go now into image size, I now have an 8x10 size to the resolution that I need for my specific printer. In the crop dialog up the very, very top here, there is a little checkbox for delete crop pixels. Now, I always have that unchecked, which means that when I crop the file, it isn't final. I can go back to that file and recrop it another way, and that information will still be there. So here, if I go to, say, an 8x10 crop, there it is, and I choose to move it up and down to wherever I want to crop the file, and I hit OK, there it is. And then I don't quite like what I've done here because I've printed it, and I'm kind of thinking, you know what, the bride's a little bit too close to the bottom. I can go back into my my crop tool. Okay, I can go back into the actual frame here, and I can still move it up and down, and that information has not been deleted. I can move the bride up, hit OK, and that information is always there. So that's like a little get out of jail clause, just in case you do want to alter your crop. Once you've maybe made a print and you sort of realize that, you know, I don't really like that crop, it needs to be, you know, moved or shifted somewhat. In order to ascertain what resolution we need to set our file to for print, we have to understand the process of how we go from pixel to printed dot. So let's just say your printer has 10 different colors to print with. Now, each dot that the printer lays down on a piece of paper can only be one of those 10 colors. Now, pixels can be any millions of colors. So printers lay down micro dots of different colors in particular patterns to give the appearance of a particular shade of color, and of course the appearance of a continuous tone. Where the confusion comes into play here is understanding PPI versus DPI. So PPI refers to pixels per inch in order to measure pixel resolution, which is exactly what we've done here, and that is what that number is. So that number is referring to PPI, pixels per square inch. DPI, however, dots per inch, is used to measure printed dots on a page. So a digital image is made up of pixels or colored dots, but millions of dots together printed by the printer is what gives us the impression of that continuous tone. So a lot of printers, like I know with the Epson printers, you know, we can print at 1440 DPI or 2880 DPI. All that is referring to is the resolution of how fine those dots can be printed on a page to give us that illusion of continuous tone. So one thing to understand is that one pixel on your screen does not equal one printed dot on your printer. So we don't have to set the number here of resolution to match what the printer is actually outputting. Okay, so let's talk about printer native resolution. Now, all inkjet printers have a native resolution. If you're printing on the Epson printer, that resolution is 360 pixels per inch. For Canon and HP, it's 300 pixels per inch. All that means is that resolution is what the printer prefers to have files delivered at through the print driver. So anytime you send a print to the printer and that print is not set to the printer native resolution, then the printer driver will resample it to the printer's native resolution. For example, if your image is set at, say, 200 pixels per inch at 8x10 and the printer's native resolution is, just say, 300, then the printer driver will resample. It will interpolate and upscale that image to 8x10 at 300 pixels per inch. Now, most of the time your printer will do an okay job, but it certainly won't do as good a job as what we can with the control that we have inside of Photoshop. So let's get back to printing on Epson. So 360, 270, 180 are the Epson recommended resolutions. Okay, now this all depends on how big we're actually printing our file. So the printer head, the Epson printer heads are currently designed in multiples of 90. So anything past 360 will run the risk of causing banding. Also, you have to understand that running that much data through a driver is going to cause all sorts of problems. Okay, so the driver rasterizes using bicubic interpolation to 2880, which is the maximum DPI that the printer is capable of, based off multiples of 90, not 60. So this is why if you're printing on Epson, we're using 180, 270, 360, and not 360, 300, and 240. Let's have a look at sharpening. So every digital image needs to be sharpened. The question is, when do you apply it in your workflow? The answer to the question, well, it depends, because you're applying sharpening at different stages and in different amounts. Now, every image shot on a digital camera needs to be sharpened. Why? Because there is a filter that sits directly in front of the camera's image sensor, and that filter cuts out some infrared light to help improve color reproduction. However, it also blurs your image just a tiny little bit to reduce stair-stepping and all sorts of other stuff. Okay, so little patterns that could appear in diagonal lines in your image and so on and so forth. So there is sharpening that we apply at the raw conversion stage. There might be sharpening that we apply aesthetically to sharpen different parts of the picture to direct the viewer's eye into certain areas. But then, of course, there is output sharpening, which is what we're going to talk about today. Now, output sharpening, we apply output sharpening just before we're ready to print. So in other words, once we have sized the image, and for the very simple reason that when we've sized the image, especially when we enlarge the image, remember that Photoshop, as I described earlier, has made up information. So new information has been made up. So, the lines that appear in your image and those edges of contrast, which is what we're going to be sharpening, have got a brand new edge because pixels along that edge have been made up. Now, if we sharpen the image before we're actually outputting the image, what happens is that, just say a sharpened line could become broken. Okay, and could become jagged because all the work that we've done during the sharpening process has actually gone out the window. So the idea is to upscale or downsize, whichever one you're going to do before you print, and then of course we apply the sharpening itself. So how does sharpening actually work? Well, the image doesn't actually get sharper. All we're doing is increasing the contrast of the edges and making those edges more visible. So as a result of that, of course, the overall appearance of the image does appear sharper. Okay. Now, the most common mistake you can make, especially at the output stage, is to over sharpen. Let's have a look at going to filter here. Let's go into sharpen, unsharp mask. And we're going to have a look at this sharpening first. We have three sliders here. We have amount, radius, and threshold. Okay, so the amount, that's pretty easy to describe because the amount is the amount. Okay, so the amount is actually how much sharpening we want to have. But now let's have a look at the other two sliders, which are extremely important. We have radius and threshold. Now, radius determines the area that will be sharpened. A low radius means only the pixels right next to the edge that has been detected. In other words, that edge we're talking about is where light-colored pixels have met dark-colored pixels. And the sharpening makes the darker pixels darker and the lighter pixels lighter. The radius determines how many pixels from that detected edge that contrast is being applied. So a high radius means a wider area will be sharpened, okay, and a low radius means a smaller area will be sharpened. Threshold is also extremely important because threshold determines how much contrast there needs to be between colors and tones for them to be sharpened. So a higher threshold means higher contrast areas will be sharpened, but a low threshold will determine that basically everything will be sharpened. So think of it this way. If I crank the radius up right here so we can actually see it in the preview, and let's crank something so we can really see the sharpening happening here. Okay, now if I go to 0, everything is sharpened, as you can see here from the picture. If I go to 255, nothing is sharpened, okay? So, and as I bring that number back, okay, we're starting to affect, the greatest areas of contrast. And as I bring it back, the lower areas of contrast. And if I bring it right back, okay, we are sharpening everything. So the idea is to find a balance. Once I size the image to the size that I need to be printing at, all I do is I duplicate the background layer, okay, and now I'm ready for sharpening. But first I need to zoom in to the image at 100%, okay, so that I need to make a visual decision as to just how much sharpening I'm going to apply here. I'm going to go into Filter, and I'm going to go into Sharpen, Unsharp Mask, okay, and we'll bring up our dialog. And as I said in the explanation a little bit earlier, amount is the amount of sharpening that we want, and the radius and threshold are really the two sliders that we need to control so that we don't get, haloing or anything nasty like that. So at the moment, we've got 1.5 and 10 as a threshold. Now, as a threshold, probably 10 will be the maximum I would go, and the radius will go anywhere between sort of 0.5 to kind of 2. So I'm going to bring and increase the the sharpening probably to about, say, 200%, something like that, okay? And I'm looking at the edges here in my close-up in my little window, and they're looking still pretty good. And if I toggle on and off, you can see the sharpening and softening sort of, being switched on and off. Those lines, especially up here where the veil is, okay, are becoming, a lot more visible and a lot crisper. So let's play around with the radius and bring that radius, say, up to 2, because I am printing this on matte paper and I want it to have a little bit more snap and punch. So turning it on and off, and I'm kind of happy with how that's looking. And once I'm happy with that, I will hit OK. And you'll note here that I have it on a separate layer. So now I can actually toggle on and off and see exactly, how much sharpening I have applied. Now, the reason why I do have it on a separate layer, at times, even at the output stage, assuming now, when you look at this image, the background is quite soft, but I want the bride to stand out, a little bit more. I might, add a layer mask into that, and with a black, with the layer mask filled with black, okay, what I can do is take a brush, fill with white, and I can make the brush nice and big, and the brush is set at 100%, and brush with white on there, and brush on basically the sharpening that I want selectively. So even in print, okay, the bride here is going to stand out a lot more than the rest of the background. Another really cool way to sharpen is to go back in the Camera Raw filter or Adobe Camera Raw and use the sharpening in there, for the very simple reason that it just gives you just a little bit more control. And the way I like to do that is, once again, is I do make a duplicate of the background, but then I go into Filter and I convert that layer into a smart filter. So what that means is that I can go into Adobe Camera Raw and I can apply sharpening, and if I'm not happy with that level of sharpening, I can go backwards and forwards and find the happy medium that I actually want. So let's go into Filter, Camera Raw Filter. And once we launch that, we go into our sharpening dialog, and there it is. And in the sharpening dialog here in Camera Raw, we have a little bit more control. Not only do we have an amount and a radius, but now we have a thing called detail and masking, which gives us an incredible amount of control. So once again, I'm going to zoom into my image at 100%. So this image, once again, has been sized and it's ready to print. Now we're going to leave our radius at 1 and our detail at 25, and I'm going to increase the amount of sharpening. And let's bring that up to, say, 100%, okay? Now, as you can see here, this has brought in not only, sharpening of the edges, but even sharpening of of the pixels. And if I zoom in a little bit more, you can see just exactly what that has created. This is because now this detail slider is coming into play, and it's picking up. So in other words, if I bring this right down to 0, it's not picking up any of the details, but if I was to bring that at 100%, right, every little pixel has been sharpened. So the idea is to find here a happy medium, but there's a really easy way of doing that as well, which I'm going to show you in just a second. The masking, of course, here at 0, we are sharpening everything, and at 100, we aren't sharpening anything. So it works pretty similar to the threshold. But now the advantage here is that we can have a visual correlation as to just where those edges are and how we can control them. Let's have a look at masking first. If I hit the Alt key on the keyboard, okay, and I click onto the actual arrow here, the whole screen goes white. So picture this like a mask in a Photoshop layer. If the masking is white, it reveals everything. So at the minute, the masking is 0 on here, which means that the amount of sharpening with the radius and detail that we have attached up the top there is being applied everywhere to the image. Now, as I start to bring that to the right, what's happening is that the areas that are coming up as black aren't being sharpened. And if I can keep on bringing that up, what am I doing? I'm just basically revealing just the edges. So this becomes a really clever way of just getting your edges really, really sharp. And at that point there, all I've done now is sharpening everything that is white, which is really the edges. So what that means here now, okay, I can afford to sort of sharpen a little bit more without affecting all the other stuff in between. I can do the same with the detail, believe it or not. If I bring that detail right down to 0 and I hit the Alt key, once again, I have a visual correlation as to how much of that, of those pixels and that noise I'm actually sharpening there. For scenarios like this, when I'm doing output sharpening, I'm going to keep that really, really low because I don't want that to be accentuated, but I do want those edges that we've masked out to be nice and sharp. I'm going to increase the sharpening there a little bit more, okay? And once I've done that, I'm going to hit OK, and it'll apply it here as a smart filter. And let's just zoom into that. Let's zoom in at 100%. So this is the layer that has the sharpening, and if I can turn it on and off, and you can just see the difference that's made purely just on the edges. For me, like I said, for output sharpening, I toggle between the two depending on the image. But I think most times I am using this method of the Smart Filter option and going back into Adobe Camera Raw just so that I have that sort of level of control over my edges, and not, especially with higher ISO images where there might be a little bit of noise present in the image, I don't want all that noise to be accentuated in my final print. Now that we've sized our image and we've sharpened our image, we're ready now to soft proof the image. So I want to talk a little bit about paper profiles and soft proofing. So paper profiles, now what is the role of the printer or paper profile? Well, it's basically to reduce, number one, the number of test prints and eliminate them altogether, which is going to make our process a lot more economical. But also the paper profile is the way that color is translated from the pixel data to the print data. So basically it acts like a translator between pixels and dots of ink on a printed page. Now, when we look at an image on screen, every pixel, as I said earlier, has an individual color with a specific color value. Now, when we print, we send that pixel color with its specific, color recipe, if you like, and the printer driver will interpret that recipe into dots of ink on a page that represents that particular color value. Okay. Now, from computer to printer, we have this translator, which is the paper profile. But however, what we can do is in Photoshop somewhat emulate how this particular profile, based on the type of paper that we're printing on, can actually affect our image. Now, before we go any further, of course, obtaining paper profiles is quite easy because we can download them from the Canson Infinity website based upon the type of printer that we're printing on and the type of paper that we want to print with. And this is what we call can profiles. And of course, going beyond can profiles, you can create one yourself, or you can get a printing bureau to create one for you. Essentially, the CAN profile, I guess, will only get you so far, whereas a custom profile is more like an individual fingerprint of the way your printer behaves with a particular type of paper. So you're going to get far more accurate results that way. Okay, so let's have a look at this image on screen and let's soft proof it. So we've sized this image, like I said, we've sharpened this image, we're ready to print it. And what we need to do is perhaps do a soft proof and see how this image is, is going to look when we apply the profile itself. So up the top here, we can go into View and we can go into Proof Setup and we go into Custom. So we have our custom proof condition dialog box that comes up, and really all this is going to do is going to ask you what device that we are emulating, and this is where we'll bring up the paper profile that we've installed in our system here, or one that we've either downloaded from the website or one that we have had created individually for our printer. The rendering intent, which I'll explain in a minute what each of these do, and then of course you've got the option of black point compensation and also the ability to simulate paper color. However, when we start to simulate paper color, we can get some really wacky results, and there is a certain way to deal with this this part of the soft proof conditions here. Let's take a look at rendering intents: relative colorimetric, perceptual, absolute colorimetric, and saturation. Two of the most common ones you will ever use in your printing workflow are relative colorimetric and perceptual. Now, what are they and what do they do? So basically, a rendering intent is a way that color is converted when we go from one device to another. So in this example that we're showing here today is how the colors here on the screen are going to go from our screen monitor profile to our printer profile. Okay, so in relative colorimetric, outer gamut colors are moved to the nearest point within gamut. Whereas perceptual, outer gamut colors are moved into a gamut and their relationship is preserved. So let's have a look at what that means. So here we have, the gamut of the image. Say up the top is the gamut of the image, and the gamut of the paper is down below. Now you can see down below that the gamut of the paper is a lot smaller than the gamut of the image. So what happens is, that bit of the information is outside of the gamut and somehow has to be brought back into gamut. So with relative colorimetric, what happens is those colors that are out are just all brought to the edge of that outer gamut range. Okay. Now, what that means is that if you have saturated colors here with detail, a relative colorimetric rendering intent, the minute you bring those colors in, might display a solid color without any subtlety of detail within those saturated colors, which is not really an ideal scenario if you are printing images with really saturated colors like sunsets and with deep blues and deep reds and so on and so forth. Now with perceptual, though, this is the interesting thing. What happens with perceptual is that you have relationship between colors of your saturated colors. That relationship is maintained as you bring them into the gamut of the paper. Now, the only thing that will change, of course, is the saturation of the colors, because effectively there is only, the saturation of what the paper can print is fixed based on the inkset and everything else that we're using. Okay, so we can't print any more saturation than what the paper will allow us to print. However, what we'd like to do is maintain the relationship of color. So saturated colors will still come across as having detail in them in our final print. Okay, so let's go back into Photoshop and let's have a look at this image and soft proof it. We'll go into View, Proof Setup, Custom. And what we're going to do here in the Custom dialog, we are going to first select the device to emulate. In this case, I'm going to be printing on a P800 Epson using the Canson Infinity profile for the Canson Barata Prestige, the 340 GSM paper, which I just love. So I'm going to select that. And then, of course, once I've selected that, I need to select the rendering intent, or basically have a look at how these colors are going to be interpreted with the paper profile. Okay, so Relative colorimetric is going to give us one version of the image. Perceptual is going to give us another version of the image. Okay, and at the end of the day, there is no right or wrong. It's going to really come down to personal preference and taste. Now, sometimes though, you have to think about things a little bit differently, especially when you have images that might have saturated colors, like I've got here in this particular scenario. And in fact, if I just hit OK with that, and I go into view and go into my gamut warning, my gamut warning here is telling me colors that perhaps could be out of gamut. Now, one thing to note with gamut warning inside of Photoshop is that it's absolute. So in other words, colors are either out of gamut or they're not. So it's not really telling us how much out of gamut those colors actually are. So it's kind of useful to know that you are dealing with colors that are out of gamut, but we just don't know at what extent those colors are going to be out of gamut. At the end of the day, let me just switch that off. At the end of the day, we know those colors are going to print, but they are going to print differently with different saturations. As I explained earlier, the paper is going to have, a different saturation limit than what your file might have. So those colors are going to be brought in a very different way. So let's go back into our proof setup and go into our custom. So here, rather than try and desaturate colors myself and try to bring them into gamut, I know that my rendering intent, if I was to choose perceptual, you'll notice how perceptual is changing the image on the screen, and the image now does look less saturated, but we know why. We know why because those outer gamut colors are being brought into the gamut to match the limits of what the paper can handle as far as saturation is concerned. So just a simple explanation of how all of this is coming together and how it's working for our print. But the final step is really up to you as to what you choose, and do a print on both and see which one would actually look best. For this particular print, I know that the perceptual, having done both prints in perceptual and relative colorimetric, perceptual did yield a better print. Right underneath the rendering intent options, we have our black point compensation box, which you can either tick or untick. Now, black point compensation helps us maintain shadow detail when converting between source and destination color spaces. I know this, as far as the soft proof is concerned, is purely an emulation of what that looks like. But in the print driver, with the Epson print driver, I can actually tick that also, so that I know that I'm going to get the best possible scenario for shadow detail. Underneath the black point compensation checkbox, we have the ability to simulate paper color. You'll note that if I check that box, the image on the screen drops in contrast. What that is trying to do is it's emulating the contrast of a printed image. You'll note that the contrast of an image on the screen can be quite high, depending on the screen that you're using, of course. Some images on screen are being displayed at perhaps maybe even 1,000:1 contrast ratio, whereas the contrast ratio of a printed image on paper usually hovers around 200:1. So what the simulating paper color does is it's trying to emulate how this image will look on printed paper. So the contrast is going to be obviously a lot lower. So at the moment here, we are emulating Barada Prestige. Now, Barada Prestige has an incredible DMAX, so it has really beautiful, strong blacks and an incredible color gamut. So the drop in contrast isn't a lot. But you'll note that when I change this from a Barada Prestige profile to something like a RAG Photographique, the contrast drops quite dramatically to a point where it makes it really difficult to ascertain what is actually happening on the screen. In fact, if I toggle here between relative colorimetric and perceptual, it's hard for me to make judgment as to which one is going to perhaps suit better my print. So what I would do, and what I strongly recommend is that you switch that off and first and foremost work out your rendering intents and work out which one you're going to use, whether it is a relative colorimetric rendering intent for this paper or it is a perceptual one, and then click on to simulate paper color, so that we can actually see and make decisions regarding our shadow details and how they perhaps might be interpreted. But really the best way to deal with this is, if I just hit OK, is to view this image at 100%. And also I would zoom in here to areas that have a lot of shadow details, and I would hit the tab button and I would totally eliminate everything else from the screen. Now, ideally, what you want to do to make this sort of work for you is look away for a couple of seconds and then look back at the screen. So what you're seeing is isn't an abrupt change in contrast. So your eyes have had time to actually settle. So we can actually go through the image and see how shadow detail perhaps is being interpreted by our rendering intent using the paper simulation. I just quickly want to touch on the gamut warning side of things once again, and just show you that your output device is very much governing the colors that are going to be out of gamut based upon the inkset and the paper you're printing on. So what I'm going to do here is I'm going to switch on the gamut warning first. So the gamut warning is switched on, and then we're going to go into View, Proof, Setup, Custom, and we're going to first emulate printing on Baroda Prestige, but using an Epson P800. Okay, so at the moment, by printing it this way, whether we're choosing perceptual or relative colorimetric, we can see there's a fair amount of color that might be out of gamut. In other words, those saturated colors we might not be able to print. Now, if I was to change printer and I go to my big printer, so my Epson 9070, which has the ability to print, I guess, a much greater gamut, what I can do is emulate this by switching on this is also a custom profile that I'm about to show you. So this is a profile that was made especially for the printer, for my particular printer. So I'll click onto that, and we see that now with a custom profile and a printer that is capable of printing the larger gamut because of the inkset that is available, we are not getting out of gamut colors. So the out of gamut, as I said earlier in this video, out of gamut for Photoshop is absolute. It's either in or out, and if it's out by a microscopic amount, it'll still show on the screen as being out of gamut. So we don't know the extent of the gamut. But however, I know that if I print this image now with my 9070, which has a bigger gamut volume that it's able to print, because of the custom profile, I'm going to get far better results. So there you have it, just a brief overview on how to optimize your files for print. So we discussed the importance of understanding resolution and how to set the correct PPI in your image based upon your output device. We've discussed how to enlarge an image to maintain the best possible quality, sharpening, when to do it and how much is appropriate for each individual image, and the different techniques that were involved there as well, and also a look at soft proofing before we print it. So I hope you enjoyed this video, and we'll see you next time.